Alright, hello for those of you that watch. This week we're moving into Module 7. We're going to be talking about machine guarding, lockout, tagout. So one more week after this and then we're done with the semester. So without any further ado, let's get in, talk about it, and I never remember my laser pointer. There. Okay, so introduction. Machine injuries can happen in a wide variety of things. Wide variety of ways. And the possible injuries you see here on the list: crushed fingers, hands, amputations, burns, blindness. All of these can happen within an industrial environment. The name of the game is safety. So anything that we can do to make the operation safer is imperative. Good rule to remember, as it says right there: any machine part, function, or process which may cause injury must be safeguarded. It pretty much speaks for itself on that aspect. So over the course of this particular lesson, we got 5 different objectives that we'll be covering. Main causes of machinery accidents, basic machinery parts, exposing workers to hazards, workplace situations that require guarding, requirements for safeguards and lockout tagout, and different types of machine guards that are used. So this lesson's actually broken up into 2 separate parts, all within this presentation. First thing we're going to be talking about is guarding, then we get into lockout tagout at the end. How can machinery accidents occur? So you're reaching in to clear something. Something gets in the way, you reach in, pull it out. Punch presses, you reach in, pull it out. Not using the lockout tagout. So we're going to learn about that, like I said, in a minute. Unauthorized persons doing maintenance. So if you have somebody that comes up and they are not authorized to do it on that machine, they are not knowledgeable on how to do it. And missing or loose machine guards. So amputations. It says right there. So this is obviously old. 2016, but I really doubt that it has changed. 1,500 worker amputations in only 6 months, and it boils down to what, 7 a day. So what that says: unguarded, inadequately safeguarded machinery. It really can be anything. As we're going to see a lot of examples in here. Guards that are not there, or guards that are improper. Material handling, just material handling is literally anything. You're moving something around from one point to another, and activities involving stationary machines. So machines that are there and the operator is working on the machinery. Talk about the basic machinery parts and the hazards. So these are the 3 fundamental areas that accidents can occur within a machine. You have the point of operation, the power transmission device, and the operating control. What we're going to do is cover those various aspects in the next couple of slides. Point of operation, that's where the work is performed. Okay, so you have the cutting, the shaping, the boring, the forming. If you're here in the machine shop, it's where that cutting tool is actually performing that operation. If you work in a punch press factory, it's where the punch press is making contact with the material itself. Woodworking, for example, it's where the saw blade is actually making contact with the wood. So power transmission device, whole slew of different things: your flywheels, pulleys, belts, connecting rods, things that are moving around, chains, gears, all of that motion. That's the power transmission. Anything that transmits the motor power into something else that is physically moving. So we have some animations here: rotating parts, drive shafts and whatnot. I don't remember. I've seen pictures of them, and I've seen them in museums. Machine shops and clothing mills, grist mills, all sorts of things like that. They were powered by devices like this, drive shafts overhead, driving belts, which actually drove the machinery. So you can imagine a lot of moving parts moving around. In this case here, we don't have that anymore, but there are still drive shafts and things like that. Chains and sprockets, belt-driven things. All of our lathes out there are belt-driven. There is a guard covering the belt drive. The mills are also belt-driven, but once again, there's guards covering that as well. Exposed chains, things to that effect. This nip points. If you get your finger caught in there, that is a nip point. Another example of nip points. We have these pedestal grinders in the shop. So that area right there can be a nip point. On my CNC machines, I have chip conveyors that are like this. This is down at the bottom of the machine, though. If there should be never any reason why your hand is down there. Flywheel spinning like that, nip point right there. So nip basically means pinch. Go to the next. Tables, kind of a interesting animation here, but you can frequently have tables that slide back and forth, and if you get stuck in between the bed and the wall, bed stationary, table moves, that could be a severe injury. Guard on that, obviously, you don't want to have an individual standing behind the machine on that, so we'll understand here what guards can be put in place to avoid that. Belts, transversing motion. It's basically just a belt that spins. It can create a nip point on that aspect as well. Cutting motion, in this case here, it's a drill. This is just a typical wood drill, but we could have something like that in the machine shop where we're drilling holes on our milling machines, or even on our drill press. So, we had a drill press in here when I became department chair that it was just all around completely unsafe, and I did not want to be responsible for any accidents in the machine shop, pertaining to that. So I ended up getting rid of that machine, got a brand new drill press to replace it. The previous one had been around, it'd been around in the shop since the 70s, but it was made in the late 40s. So, a lot of safety aspects didn't exist back then. So, I ended up getting rid of it. Punching and shearing. In this thing here, we see this is punching some holes into a feature. Shears. We've got a shear similar to this over in the welding shop next door. Obviously, if you look at either one of these things, if you get near that cutting edge, the machine is not going to know the difference between flesh and steel. It doesn't stop when it detects it. So there is hundreds of tons of pressure that are driving these things. So you don't want to get near them. Where's my next button? There it is. So machinery requiring guarding. Cutters, shears, alligator shears, power presses, milling machines, power saws. Basically, any type of power machinery probably is going to require some sort of guarding in place to prevent somebody from, becoming injured, becoming in contact with those cutting areas. Pedestal grinders, like we see right here, I have several in my shop. A lot of people have them in their home garages. This is an OSHA requirement, and we get dinged on it frequently because a lot of times a student will use the grinder, grinds the wheel back, and does not adjust it. OSHA requirements state that there needs to be a maximum opening between the wheel and this rest right here of 1/8 of an inch, maximum 1/8 of an inch. And then up top is the tongue guard, maximum 1/4 inch to the wheel. So if you ever see any of those things that are out of spec, then you're going to need to adjust. This rest will slide in and this tongue guard will slide down. It is to prevent from, if Granted, yes, if your finger gets caught in there, it will take off the end of a finger, but the purpose of this is that it's just a finger and not an entire hand that goes in there. On the same aspect, if anything were to get drawn into there as it gets slung around the grinding wheel, the tongue guard here is going to keep it from coming out and getting shot out at you. So there is a purpose to have both of these devices on your pedestal grinder machines. Obviously, we see there the ends have guards as well, cover the end with the nut and the flange, because there's spinning motion on the end of that. Going on to the next, revolving barrels and drums. A lot of times we'll see these things in facilities. They'll have like a rock tumbler, and this is spinning. Has to be guarded by an enclosure. It's interlocked, meaning that if you open the door, everything stops motion. Guards with openings. So if you see these openings here, no larger than ½ inch, so nobody can stick their hand in. This is obviously very unsafe. This is an unguarded belt and pulley, and his head is literally right next to that. If that were to turn on for whatever reason, it could be very serious. So these things need guarding. It says right here, if they are less than 7 feet from the floor or a working platform, they must be guarded. So if they're up in the air, that there's no risk of anybody going near it, then it doesn't need to be guarded. But anything that anybody can get access to within 7 feet needs to have guarding around it. Machinery associated with the amputations, there's so many out there. Drill presses, milling machines, meat cutting, bandsaws, things like that. Safeguards. The requirements for safeguards, preventing contact. You don't want to, it's going to prevent contact with the cutting area. They have to be secured. They can't just be hanging out there freestanding. It needs to be secured to the machine. Protecting from fallen objects, so if it knocks it out of place, it doesn't create a new hazard. The last thing you want to have is something that's preventing a hazard, but it's creating a new hazard in the meantime. Create no interference, meaning it doesn't interfere with the actual cutting operation, and safe lubrication, meaning a lot of machines need lubrication, and is there a guard that's preventing lubrication from occurring, which can then ruin the machine in the meantime. We have primary methods of safeguarding our machines, guards, and specific protecting circuiting devices. They ensure employee protection. They're properly designed, constructed, and installed. So you can't just have somebody that says, "Oh, this is a good idea, let me do this." Not properly designed. It may not be properly constructed. Is it made out of something that's easily going to break? Is it not properly installed? Is it just sitting on a machine versus being properly fastened and installed to the machine? So a lot of things have to be taken into consideration when safeguards are brought into place. And obviously, are they used and maintained in good operating condition? Hey, the guard was fine 20 years ago when we put it on, but the plastic thing is all broken off and no longer effective, So obviously these things need to be upkept. Some secondary methods: probe detection, safety edge devices, meaning if it makes contact with something. I've seen powered industrial lifts which are automated, and if they bump into something, it'll automatically turn it off. So if there's somebody standing in the way, it'll automatically stop motion because they follow a track on the floor. Safety light curtains. That's what this thing here. Those things are really neat, actually. If there's an area on the other side of the curtain that is in motion, if anything breaks this beam, it will shut the machine off. So it's not necessarily a wall or a door or a cage or something to that effect, but if you were to reach in there, it will stop the motion. One of the most known examples that I can think of in your house would be the automatic garage door opener. If you've ever had a bike or a car or person standing and breaking that beam, the garage door either won't work, or while it is coming down, it will reverse the door and come back up. Safeguarding methods have to be at a safe distance. safe holding, safe operating. And the last thing, obviously, none of this works if there are not safe work practices put in place. So, if they say, don't put your hand in there, if these things are not being relayed, then all of this is put to waste. Different types of machine guards. So we've got 4 general types that we're going to cover in the next couple of slides here. Preferable to other control methods because it's an actual guard. It's the physical barrier that prevents contact with those parts. So, if I go back a slide, that is not a physical guard, whereas this on this saw is an actual physical guard. So we have the 4 types: fixed, interlocked, adjustable, and self-adjusting. We move along and we'll discover what they are. So your fixed guard is a permanent part of the machine. So here we see a permanent part of the machine. Here it's a cage around it, permanent part of the machine. Next here, the interlocked guards. It will shut off the machine if the guard is moved. My CNC machines have interlocked guards, so if the door is open, the machine will actually shut off. It doesn't shut the machine off, but it stops all motion. And some of them are actually locked to where you can't open it while the machine is open. Some of the older ones that I have are not locked. However, as soon as that door opens, the machine will shut off. Adjustable guards, we have them on our saws in the back. You're able to adjust them based on your workpiece height. Some of these, prevent starting when the guard is open. If the guard is not in a proper position, or if you take the guard off, the machine won't work. And then the self-adjusting. I know, and I've seen it, these things are frequently removed from table saws. Not a good idea, but it happens. But this is self-adjusting. So obviously it'll go up and down depending on your workpiece height. You don't have to adjust it. It's automatically adjusted. But it prevents accidental contact with that saw blade there. Pullback devices, really kind of an interesting concept. If a worker's hands, and I'll go to the next slide here, you can read through that real quick, but automatically withdraw his hands from point of operation. Next slide has some better photos. You see it's wrapped around this individual's hands. As the ram comes down, it's hooked up to some cables. If I go back a slide, hooked up to some cables, and as this goes down, it pulls and will then pull their hands out of the machine as the die or whatever is happening is coming down. So interesting concept. One of the big things that I think that is probably a leading cause to injuries is complacency. You've been doing the same exact operation for 1,000 times today, and you just go through the motions, and you forget. This kind of a neat little concept. Two-hand controls need 2 hands to activate the, in this case here, the press is moving in a downward motion. Both need to actuate in order for it to work. It's nice, if one button is not pressed, then the machine won't work. So if your hand's inside the machine, you press it, nothing's going to happen. This one here, it's a gate. Gates open, gates closed. Like I said, my CNC machines have some gates on them. Our wire EDM here in the shop has a gate on it. Machine will not work unless the gate is properly closed. There's like a safety interlock. It's a switch. Makes contact with the second part of the switch. If it's open, the machine cannot function. If it's closed, the machine will function as intended. So that's kind of a rough overview of machine guards. Basically, the point is, if you see motion, then that motion needs to be protected. Like I said, these machines don't know the difference between a human and whatever material it is that it's working on. So if that area has been safeguarded and protected, then the risk of injury is decreased. Next up, we're going to talk quickly about, I only have a couple of slides on this, lockout tagout. There we go. Lockout tagout. We have a tag, danger tag, equipment locked out by Kevin. It says it right there. It says on the back, this tag and lock are removed only by the person shown on the back. Padlock and this locking mechanism here. So see some, essentially the whole point of a lockout tagout. You see there, control the unexpected energization, yeah, I'll just skip that word, energization or startup of the machines or equipment. If it's locked out, it cannot unintentionally be started up. If I move on to the next one here, here's an example of, there can be hundreds of types of devices. The whole purpose of the lockout tagout device is to keep the machine from starting up. It can, anything that prevents it from starting up unintentionally is a good lockout tagout. All it needs to be is identifiable. It needs to be identifiable that it is in fact a lockout tagout. Danger, do not operate. A couple of devices here. These are to keep from valves being turned on and off. I'm not sure what those are. Maybe some switch protectors. This is a switch protector to keep a circuit breaker from being turned on and off. These here, it's the same device that I have right here. It's to prevent a main power from being turned on and off. Your padlocks, some cables, and a lockout box. If we go here, we see this is a lockout box. This is interesting. If you're working in a facility that has an industrial facility that has several different individuals working on a piece of machinery, hydraulics, electricians, carpenters, whatever, all of these people are working on it. Instead of them all having their locks on here, but if we see here with this particular thing, see there's six openings, that means 6 padlocks can go on here. And all 6 locks have to be removed before this thing can open up. So on this one here, instead of having all of those locks on there, there will be one master lock locking the machine, and then you'll have all of that, the key for that master lock is inside this box. And then all of the individuals will put their own locks on here. So the only way to get to the key that's inside this box is to have all of these locks removed. So a neat little thing there. OSHA talks about an authorized employee. In this case here, it's the employee who locks out that machine to perform the maintenance of the equipment. The lockout is used for those employees for their own protection. If you look at one of my videos that I put up on Blackboard, just kind of some examples, there's an individual that's inside of a machine. He has it locked out for their own safety. It's not for the safety of the machine, it's for the safety of the individual working on the machine. With anything OSHA related, there has to be a procedure. So in this case here, you have to have the intended use of the procedure, steps for shutting the machine down, isolating it, things of that nature, the procedures for the placement of your lockout tagout device, and then the requirements of testing the equipment to determine if the lockout tagout has been effective. So if you lock a machine out and there is some way to get around that lockout, then obviously that lockout is not effective. Different types of energy sources that can be locked out. Any of these 6 that we see are different types of energy sources. There may be more mechanical, hydraulic, chemical, pneumatic, electrical, thermal. Any way to stop those energy sources is a method of lockout and tagout. We talk about lockout tagout application. Affix to the energy isolating device, so turn off the power, affix your lockout tagout in a manner to hold it in a safer and off position. If it's just like a lock, or not a lock, if you take this zip tie right here and just hang it over the emergency stop, that is not a way to lock the machine out. It's just sitting there, but it doesn't really work. And it prevents unintended motion of the machine. That's kind of one of the big things. And then lastly, after the machine has been locked out, we talk about the removal of it. This is big. This is really big. On this case here, it says equipment is locked out by Kevin. Okay? So I am the only authorized individual to remove this tag. The only exception is when I am not available, it may be removed under the direction of the employer. So in this case, if I were to lock something out, now in our machine shop there's only two of us. So if I lock something out, Nat will know that it's been locked out. And both of us are working on the machines, but if he needed to unlock it for whatever reason, and I'm not here, he would probably call me to say, hey, look, is that machine to be safe to be unlocked? For all he knows, I could have something removed from that machine, and if it's, if he just goes over and unlocks the machine, then, injury may occur. So just because we're the only two here and we know, what each individual is doing, we're not going to remove that lockout unless we have received authorization from the other individual. And everywhere I've worked, and this may be across the board, I don't know, a lot of these places, if somebody other than the authorized employee removes that lockout tagout, it is an automatic fireable offense. So when in doubt, if you see a lockout tagout on a machine and that is your machine that you're supposed to be running, you need to contact your supervisor. You need to figure out why that lockout tagout is on there. And only when that supervisor comes over, and I've actually even told my supervisor, they say, hey, you can go remove that tag. And I say, I'm not removing that tag. I'm not going to be the one to remove the tag. You are, because you're the one that's telling it's okay. So keep that in mind. Lockout tagout is for an individual's safety. It has nothing to do with the safety of the machine. There could be somebody working inside that machine that you don't know is there. And if you operate that machine, you can either injure or kill another employee. So keep that in mind. 27 minutes. I think I'm doing good on this one. That's the end of this slide. As usual, any questions, you can come and see me right here in the machine shop. Most of you guys know who I am anyway. Until then, we'll see you next week. Thanks for tuning in.